A density curve is a mathematical model of a distribution. So you can take a histogram and kind of sketch what a density curve would look like. So you're kind of trying to make the shape of a normal curve over a histogram, or any type of shape over a histogram. And by definition, the total area under the curve equals 1. Or if you find the probability or the entire percentage, you would want to consider it 100%. And it's also proportionate to where it's located. So like, let's say, for example, let's say that was 7. Okay? Then the proportion or the area of 7 and below would be taken up by this amount of space in here. And we would say probably less than 1, probably less than a half. Half is like right up here. So maybe only 20% might belong in there. And sometimes you'll even be given something like this. That the area is 0.20. And then you might have to find out, like, let's say the percentage or the proportion of it. %, then it would correspond to 20% of the numbers would be 7 and below. They're pretty easy when it comes to that. They can come in many different shapes. So if it didn't work out perfectly to the histogram being a normal curve, this is more of a normal curve. It could even be something like this where it's a histogram that you can make into a density curve. That would be called uniform. Then, of course, there's skewed to the left. Skewed to the right. And all of these shapes in a density curve would have an area of 1 underneath. Some of them are not even having a mathematical term. They might not have a mathematical term at all. For the normal curve, let's go back up to the top. For the normal curve, the mean and the median lie in the middle. Okay, so the mean and the median would both be here. And for density curves, this is definitely the balance point. The median is where 50% is below and 50% is above. So that would kind of be similar to this one. And for normal curve, this would also be for anything symmetric. So it doesn't necessarily have to be just for a normal curve. It would be anything symmetric, and I'll show you an example of symmetric at the bottom in a minute. Uniform would be something where there's no variation. It's all straight across the top, or very much like considered symmetric, because both sides are the same. So your mean and median would also be located like right in the middle, and that would be where you'd be able to balance it. Skewed to the left Remember, the mean is pulled into the tail because of those outliers. And the median would be somewhere above it or greater than it. And remember, median would be 50% of the data is below, 50% of the data is above. The mean would be right where you could put a pinprick right below here and balance the curve on it. So this, in order for it to be so much into the tail would have to be very long. Skewed to the right, mean is into the tail. Median in this case would be lower than it, smaller than it. And same type of things with this type of unknown distribution. You don't have to worry about where the mean and the median would be because it would be different for each one. Symmetric, something that I've showed you before. Symmetric is something like that. If I could try to make it as symmetric as possible. Mean and median would all be in the same spot as the normal curve right in the middle, although it wouldn't have the same properties as the normal curve. And the other thing to make sure that we talk about is that the x values are always positive. You always need positive values to be a density curve. So we wouldn't want to go dip below the x-axis. We'd want to have it be all above the x-axis.